This is a presentation on the fate of the aortic arches of birds and mammals. Although the number of primitive arches is still debated, fish and tetrapods, including both birds and mammals, typically show 6 aortic arches during early embryonic development. As seen in this photo over here of the primitive aortic arches, they are labeled from 1 to 6 in Roman numerals, with arch 1 being the furthest from the heart and arch 6 being the closest right here. Birds and mammals are some of the species which are furthest descended from the original species, which contained all 6 of the aortic arches. As you can see down here, all 6 are present in this ancestral species, and then in the closer relatives, such as the shark and the lungfish, most of these are present. But by the time you get to birds and mammals, very few are present. But they have adapted and changed to their lifestyle to fit what they need physiologically. Okay, so the fate and function of bird aortic arches. As the bird develops, arches 3, 4, and 6 persist, while arches 1, 2, and 5 disappear or develop into other structures. Arch 3, as you can see right here, persists as the internal and external branches of the carotid artery, which run cranially to supply blood to the head and brain. Arch 4, right here, persists as the right aortic arch, which combines with the dorsal aorta to form the right systemic arch. This moves caudally toward the lower half of the body to supply blood. And then arch 6, right here, creates the pulmonary circuit. It persists as the pulmonary arch, supplying blood to the lungs. Mammalian aortic arches for the fate and function are very similar to the birds. As in birds, the only arches to persist in adulthood in the mammals are arches 3, 4, and 6, although all 6, as the birds did, still form embryonically. They are similar to the birds, but there are differences in orientation and the mirroring of some arches. Arch 3, right here, persists as the internal and external branches of the carotid artery, as it does in birds, and it supplies oxygenated blood to the head and brain. Arch 4 differs from birds in that it persists as the left systemic arch. It's the right in the birds, and it combines with the left subclavian and lies underneath the subclavian artery. It moves both caudally and cranially to provide blood to the trunk and the lower body. And then arch 6 creates the pulmonary circuit. It persists as the pulmonary arch, supplying a flow of blood to the lungs for gas transfer. So now we're going to trace the blood flow through the bird's circulatory circuit. The flow of blood through a bird's body has been perfectly adapted to supply copious amounts of oxygen to the body systems, allowing efficient and sustained flight. Birds, like mammals, humans included, have a 4-chambered heart, which allows for complete separation of the oxygenated and deoxygenated blood. Because of this separation, there are 2 different systems, venous and arterial, which are used to carry the different blood. Okay, for the venous system, it carries deoxygenated blood from the body tissues and structures back to the heart to be returned to the lungs for a fresh supply of oxygen. So for the cranial blood flow, the blood flows to the heart from the right and left, or the anterior vena cava or precava, depending on what species you're talking about. In humans, it's the inferior and superior vena cava, but in animals, it's typically referred to as the precava. So that would be this area right here. It flows into the heart. Tracing it backward, it branches caudally into the pectoral vein right here, and this is mirrored on both sides. It branches caudally into the pectoral vein, which carries blood to the chest muscle, from the chest muscles back to the heart, and then the brachial veins as well, which carry the blood from the limbs back to the vena cava or precava, as well as the right and left jugular vein, which runs right here and joins to bring blood into the right atria. On the left side, the precava, anterior to the vena cava, branches into the left pectoral, right here, and then the left brachial, and then also the left jugular. And these two articulate at the transverse anastomosis of the jugular, which carries blood from the facial features and brain. And all of this blood is being carried toward the heart to be sent to the lungs to be reoxygenated. So if it starts up here, it flows downward, collects into the precava, and then comes into the heart. For the caudal blood flow, the blood flowing toward the heart from the caudal end of the bird starts in many locations. The blood meets at the post cava, or the inferior vena cava, right here. The post cava, moving caudally, branches into the hepatic veins, which lie right here. On the right side, carrying blood from the liver, there's also a smaller branching vein called the epigastric vein, right in this area, which carries blood from the stomach. It further branches into the right and left common iliac veins, right here, carrying blood, and then it develops from the common iliac into the right and left femoral veins, which lie right here and right here, and those carry blood from the hind limbs. From there, it goes down and develops into the renal and sciatic, carrying blood from the kidneys. Below the kidneys, it branches into the renal portal veins, and then into the internal iliac, which are on the right side, and the caudal vein. This is the internal iliac, the caudal vein. Here's another internal iliac on the other side. And then from there, the left renal portal vein branches into the posterior mesenteric, carrying blood from the intestines. Following this back up, toward the heart, the posterior mesenteric meets the anterior mesenteric, right here in this little bundle, and the gastroduodenal veins at the hepatic portal vein, which is this larger portion, which connects back to the inferior vena cava to be brought back into the heart. For the arterial blood flow, the arteries in the body carry oxygenated blood from the heart to the body systems. The arteries lying over the heart in a net-like fashion, the coronary arteries, supply blood to the atria and ventricles of the heart themselves. So tracing this blood flow cranially, the blood from the left ventricle of the heart is pumped out into the aorta, which branches nearly immediately to provide blood to the caudal and cranial ends of the body. On the cranial aspect, moving toward the head, the aorta branches to become the dorsal aorta, which continues downward to supply blood to the caudal end of the body. The right innominate artery, which lies right here, and the left innominate artery, which lies right here, this larger branch. The right and left innominate arteries move distally to become the right and left subclavian arteries, as you can see, right in this area, kind of between the branchings. From these right and left subclavian arteries, the arteries branch upward to become the right and left common carotid arteries, as you can see here. The internal carotid, the common carotids branch to become the internal and external carotid arteries, and the internal carotid artery supplies oxygenated blood to the brain, while the external carotid arteries supply blood to the face and neck. Returning to the right and left subclavian arteries down here, as we move distally to the carotid branches, the arteries branch to become the pectoral and brachial arteries. As you can see in these lower, right here, here's the brachial, which will go out into the limb, and the pectoral, which is larger, especially in birds because they have those large pectoral muscles, will supply blood to the chest. So finishing up the bird blood flow, the caudal artery blood flow, if we follow the descending aorta, or the dorsal aorta, it carries oxygenated blood from the right ventricle through the body, tracks caudally through the abdomen to supply the blood to the lower half of the body. The dorsal aorta, once inferior to the heart, so down in this region, branches to form the celiac artery right here, which supplies blood to the stomach, as well as the anterior mesenteric arteries right here. And then it continues. This supplies blood, the anterior mesenteric supplies blood to the connective tissues and to the intestines. And then it continues down here, following the dorsal aorta. It branches again into the kidneys. The dorsal aorta continues to branch to form the anterior renal, middle renal. Here's the anterior renal. Here's the middle renal. And here's the posterior renal arteries. The sciatic artery, which persists in birds but does not in mammals, branches between the middle and posterior renal arteries right here and persists through the kidney. The femoral arteries, which lie over top of the kidneys, similarly to the sciatic arteries, diverge from the dorsal aorta below the anterior renal arteries, supplying blood to the entire lower limb. As the dorsal aorta continues past the kidneys, it splits a final time into the posterior mesenteric, internal iliac, and caudal arteries. The posterior mesenteric arteries supply blood to the large intestine. The internal iliac supplies blood to the reproductive organs and pelvis, and the caudal artery carries blood to the tail and the most caudal aspects of the body, even past the cloacal aperture. For mammals, I chose a human reference since we're all very familiar with that standard, and it's very homologous between species. So for venous blood flow, mammalian and bird blood flow is strikingly similar, with nearly all the same arteries and veins supplying the same structures in both types of animals. So for the venous blood flow, though the heart does lay slightly to the left of the medial body line in mammals, the veins and arteries are mirrored on both sides of the body. The venous system originates from the organs and tissues from which the veins are carrying the blood to the heart. Cranially, the deoxygenated blood flows from the brain through the internal jugular veins. Blood flows from the face and neck through the external jugular veins. These veins meet at the subclavian vein, which lies below the clavicle and collects blood from the axial veins, which branch down the arm into the brachial and pectoral veins, such as the cephalic and basilic veins. These subclavian veins carry blood back to the pulmonary trunk, where the superior vena cava collect the blood and carry it to the left atrium to be pumped to the lungs through the right ventricle. Caudally, the blood moves up the lower half of the body toward the heart through the great saphenous vein, which is in the lower limb. This lower vein meets with the femoral vein and continues into the iliac vein. The iliac vein meets the renal vein to collect blood from the kidneys, and then the hepatic vein to collect blood from the liver. These veins empty into the inferior vena cava, which meets with the superior vena cava to carry the blood through the heart and into the lungs. For the arterial blood flow, which matches very closely to the venous blood flow to ensure that oxygen can be replaced and removed from these tissues,